networking, security, and Wireshark.
For those of you who have used NetProbe, you'd be happy to learn that I'm developing a brand new feature, which is an internet speed test. So many of you have requested this feature in the chat and on the Discord, and I thought I would actually spend some time over the last couple of weeks in developing it. But in developing this, I actually ran into some issues within Docker that I needed to resolve, and I used Wireshark to do it. So I thought I would actually use this opportunity to teach you a few techniques about resolving issues, specifically network issues, from within containerized environments. So to show you what the issue was, here I have a very simple speed test script. Now I'm using a module known as speed test CLI. I'll put the link to the module in the description, but it's a fairly simple module. It replicates what speedtest.net does and other speed tests. It downloads a bunch of files, it uploads some files, and it actually reports the data to the user. Now, what I'm finding is that running this module or this script from my host machine, I get my full internet speed at my correct latency. So 60 megabit per second down, around 10 to 12 megabit per second up, and about 25 milliseconds of latency to the nearest server. When I run it from within the container, I'm only getting about 2.2 megabit per second down, 2.6 megabit per second up, and 2.5 milliseconds of latency. So clearly something is not right. And before I can actually release this feature, I need to understand why I'm getting this, because obviously we need to ensure that this test is actually accurately measuring speeds from the host, not necessarily from this container where it could be smaller values. So let me show you how I did that. So a little bit of theory. Docker runs on a host machine. In this case, it is Linux. Within the host machine, Docker creates this virtual network where you have the actual containers running. Okay, the Docker host connects to the router switch, and the router switch connects to speed test servers over the public internet. So you can understand why I'm a little bit confused as to why running the script from this location, which sends my traffic this way, gives me full speed, and running it from inside a container on the same machine, basically going through the machine itself to the router switch and then to the same path, yields, much smaller bandwidth. So in order to troubleshoot this, what I need to do is actually get some capture files, some PCAPs. So what I'm going to be doing is actually showing you how to run a PCAP from the container itself, so that you can actually investigate what's going on from a network perspective when that traffic is downloaded to the container. And I'm also going to run a PCAP on the host machine when I run that script from the host machine itself outside of Docker. And that way I can compare the two. I'm also going to show you some techniques on how you can actually prepare a Docker container image for troubleshooting specifically. Just to take a second to explain the Docker file and how we're actually going to build it to help with troubleshooting. So first off, I'm actually going to start from an image that contains Python, because this script is in Python. Python 3.7 Slim Bookworm. This is actually the same image I'm going to be starting to use with NetProbe. I'm going to copy the requirements file into the actual container image. This is so that we can actually install the packages. The packages are really just the speed test CLI module for Python, and that's in the requirements file. The second thing, I'm going to set some environment variables for Python and for pip. And then I'm going to do an apt-get update, apt-get install of tcpdump, so I can actually take the packet capture, clean, and then from there, pip install requirements. So the module and requirements helps me run the actual speed test, and then tcpdump actually helps me do the packet capture. So this is the Docker file. I'll also upload this to the repo that I'll post so that you can use it if you want to practice this. But really, you could have the same kind of technique even if the base image is different. If you're working on an existing project, what you could do is use the image that you're already building for that project and really just inject tcpdump into a build. And then when you build it with a tag that's not your primary tag. Do it dash troubleshooting or something like that, so that you could actually get tcpdump installed or whatever other troubleshooting utilities you want. And that way you could execute the same code that you're working on, but in an environment that has the tools you need. To get started, I'm going to build the image so I can use it. So I'm going to do docker build current working directory, which picks up the Docker file in the directory I'm in. I'm going to tag it with speed test latest, just so I have easy reference. And I'm going to let that build. When it's done building, I'm going to come back and I'm going to show you how to use the image. So the image is built. And now what I'm going to do is I'm going to run the image in this terminal, and I'm going to jump into the image in a second shell session in this terminal. I'll show you how to do that. So to run the image, what I'm going to do is docker run IT for interactive. I'm going to do V for volume mount. I'm going to mount the current folder to the code directory within the container. I'm going to use the speed test latest image. And I'm going to run bin bash. So this is getting me set up on one side, and I'm going to leave this here for now. I'm actually going to run the speed test in this terminal, and I'm actually going to do the TCP dump in this one over here. So let's go over to the other one. Now, I don't want to run a new container with this image. I want to get into the same one. So I'm going to do docker ps. I've got a bunch of stuff running here, but I'm going to find it. It is going to be speed test latest. Container ID is this. I'm going to copy that. And I'm going to do docker exec instead of run IT, my container ID, and then I'm going to do bin bash. And now I'm in the container. Now these should have the same ID. They do. And we can get started. So the first thing I want to do, I want to start TCP dump on the right side. TCP dump. NNI, any. It just turns off name resolution. Any interface. I'm going to do no host filter because I don't need to filter. I want everything. I want to do write to docker.pcap. And I'm going to do verbose. Verbose is nice because oftentimes when you do it with write, you don't actually see the packets in the CLI. So this actually tells you how many packets you're capturing. So you can have an idea if your capture is going well. Let's do that. Got 0, which is good. Now going back to the left-hand side, I'm actually going to run the speed test. So let's go into the folder code. And let's run python speeder.py. And you can see the traffic is starting to pick up on the right. And we're going to let this run. So this takes a few minutes to run. So I'm going to let it run. When it's complete, we'll come back and we'll take a look. And we're back. So you can take a look and see. It's pretty funny that the actual speeds come out to be the same thing every single time I run it. But again, 2.3 megabit down, 2.6 up, and 2.5 seconds of latency, which is completely wrong. So what I'm going to do on the right side is I'm going to stop the TCP dump. You can see I captured about 8,600 packets. Now, the nice thing about doing it this way, with the volume mount of the actual code folder to within the container, and then saving the TCP dump, is that what you can do is from within here, you can find that file. So you can see here, where do we put it? Docker.pcap. I'm going to do move docker.pcap to code. And if I actually go back into my host, look at the Explorer, I now have docker.pcap. So I can easily now just download this or open it if it's my local machine. And I'm going to download it to downloads. I already have one Docker. I'm going to save it. And then I can open it up. So that's one PCAP. Now I need to get another PCAP from the actual host. So what I'm going to do, I'm not going to show you this on camera, but it's the same process, except I'm going to run the same speed test from the Linux command line outside of the image. So I'm going to exit this. Both of them close because the image is dead. And then I'm just going to run this exact same code because I'm in the folder. I'm going to do Python. I'm going to do speeder.py. And let that run, and we'll look at the PCAP. So next step, I'm actually going to open PCAP for the Docker one, open the PCAP from the host, and we're going to compare them side by side. Okay, so I've got my two files, speed test host. This is taken from the host machine. Again, this is the Docker machine host. And then there's also speedtest.pcap. So let's start with speed test host. This is the one that I know that works and shows me the actual correct download and upload rate. And it's always good when you're comparing two PCAPs for the same function, maybe on two different machines, to look at the one that actually works first to understand how it's supposed to work, and then you move to the one that doesn't to see what the differences are. So the first thing I always like to do is scroll through the capture file to actually take a look at just how the order of operations works. Now, I've got a lot of SSH traffic here. I'm going to ignore that for now. What I'm looking for to kick this off is some kind of DNS query to speed test, because generally you think about that's probably how it starts, right? You've got to connect to the speed test server. DNS would be your first thing. And there we are, right? We have a record request and a quad A request to speedtest.net. We get the response back. And then lo and behold, we have a SYN going out to 104.18. 104.18, if this response is what I think it is, the answers, it is 104.18. So this is speed test. Okay, so we kick off a HTTP session to speed test. There's HTTP. We're getting a speed test config file of some kind. Looks like we get a server list here. Okay, so we're doing just basic plain text HTTP. I can go in and look at it to take a look at what they're actually pulling, but my assumption this is a server list or speedtest.net. And then more SSH. Okay, we've got some more HTTP. Let me just filter down to HTTP. Oh, and this makes it easier to look at. So we've got speed test, servers list, speed test. Okay, we do some connections to looks like various servers. So 184, 208, 90, 208, 52. And then we actually do some gets of files. Okay, so what I can tell from this is that it looks like this first portion here is basically finding the closest server and getting the server list. And then we have a bunch of gets to some random files. Looks like JPEG files. And I'm assuming this is the speed test portion. Okay, so let's just scroll through. We see, okay, the size of the files has gone up, 350 JPEG, 750, 1000, 1500, 2000, 3000, and then we see upload. So my assumption is going to be that like up until the point we get to here, we are doing download test. And then when we start posting, we then do the upload test. So I'm going to just mark a few spots. I'm going to mark this point here. I'm going to mark this point here at the start. Now, one thing that I like to do, if this is actually a speed test, then that should be reflected in the bitrate. And so let's graph that. So I'm going to I'm going to clear the filter first of all. I'm going to stats IO graph. And in my IO graph, I'm going to make sure there's no filter. I want it in bits. And I want to take a look at how many bits per second I'm seeing. Now, remember from earlier, my download rate was just over 60 megabit per second. My upload was just over 10. And if you don't know scientific notation, this is 60 megabits per second or 60 million bits per second. And this is 10 million bits per second or 10 megabits per second. So it looks like what happens is that around 5 seconds in the capture, we run up to about 65 megabits per second. We're consistent at about 64, 63 megabits per second. And then it drops down and then we go in the other direction. Now, this is just showing all bits, not in a certain direction. If I actually want to look at in and out, what I can do is I can do IP dot source equal 10, 0, 10, 150. This is my server that I'm running this from. And this is going to show me the upload test. Okay, so this is me sending data, and you can see here at 15 seconds, just like the previous graph, the upload goes up to just over 10 megabit per second and stays up. Okay, so the upload test looks like that. And if I want to switch the direction, I can go back and change this filter to ip.dest. And this is the download test. You can see it goes up to the 60 again. So this all looks pretty normal. You do some queries and DNS queries in this first 5 seconds. You find out a list of servers. You get where the closest server is, whatever function speed test has to do that. You do a download test, and then you do a subsequent upload test, and then it reports back. Okay, so that all looks pretty normal. Let's switch our gears to the other file and take a look at what that looks like. Okay, switching gears now, I'm in the speedtest.pcap file. This is the pcap taken from within the container in this virtual network in Docker. And this is the one that's problematic. So let's replay what we know about the previous test that was good and see if we can see any issues with this one. So right away, we know that with the last one, within about the first 5 seconds, we did some DNS queries, and then we also got a list of servers that we were able to use, and then the speed test kicked off. Okay, so the easiest way to see if that is about what happens here is to do the IO graph again. I'm going to open an IO graph, and I'm going to take out the filter. I'm just going to look at everything, and yikes. So this is different in a few ways. One, the traffic doesn't start in earnest after 5 seconds. It starts at about here, which is 90 seconds in. So that's not right, or at least according to what the other file looks like. The other thing is that when the transfer rate starts going through, I get a peak up here of what looks to be about 15, 16 megabit per second. And then this one at about just over 10. And I don't know what this is. That's not right. So first of all, what I want to investigate is what's going on that one is delaying this file transfer. And two, overall, it actually looks like there's a lot less data transferred. And I can tell that just because if you know anything about calculus, like the amount of data transferred here is going to be the integral of this graph, which is going to be the area under the graph. If you remember the previous graph, right? The area was actually pretty big. Let's see if I can open up that again. Let's go to IO graph. Oh, speed test host. Let's go to statistics, IO graph. Now let's take a look at this. You can see, yeah, this is a huge amount of area. So if I'm looking at this in terms of bit rate, or in terms of bit volume, like the volume of traffic, amount of data, this is a lot more data than looking at this, right? This is a much smaller section. And then the rate doesn't even get as high as the other one does. So let's do another comparison of these two side by side. Let's look at the conversation list. Because in theory, if both these captures have the same application running, they should have similar conversations, and the conversation sizes, meaning like the sizes of the files you're downloading, should be the same. So let's start with the host one. Let's go to statistics, conversations, and let's look at TCP conversations, and let's filter this by the amount of bytes. I want to see the biggest conversations we have. You can see here, the biggest conversations, it's to this speed test IP. That makes sense because we're talking to speed test. But they're up into the 8 megabytes, 7.5 megabytes, 6 megabytes. Let's do the same thing on the other capture. So let's go to speed test, statistics, conversations, and let's sort it by bytes. And right away I see a problem. So these conversations are to the same IP address, running the same function, speed test function, but these conversations are much smaller in total bytes. These are the largest ones in the capture. That explains what I was seeing in the graph, right? Which is, my presumption was that because the graph looked like it did, there was less data transferred. And if you actually look at this, overall, there's less data transferred in the one running in Docker versus the one running on the host. So what could be causing that? That is different in Docker, or running it in Docker, that is not present when running it on the same host with the same network stack, right? The same physical machine going to the same internet connection. So what I actually want to dig into is that delay at the start, right? Remember we talked about how within the good test, it went after 5 seconds, and the bad test, it went after 90 seconds. So let's figure out why that's happening. So let's go to the one speedtest.pcap. This is the one in Docker. Now, the one thing I noticed right off the bat, Wireshark is really good at coloring certain error messages with a certain color. In this case, this is ICMP destination unreachable, port unreachable. This message is generated at times when you try to communicate with a server that is not listening on a certain port. Now, not all servers do this. Actually, a lot of them these days disable this because they don't want to have to reveal that there's a server there, right? It's a security thing. But in this case, we get a reply from 172.17.04, or sorry, from 104 to 172.17.01, saying destination unreachable, port unreachable. So what's going on here? So let's just track this through. We have a DNS query going out from 0.4, that's us, that's the actual Docker container, going to 10.0.10.150. This is actually my server. This is actually IP of my server itself. Because lo and behold, I actually am running, on top of running this Docker virtual network running speed test or netprobe, I'm actually running Pi-hole DNS. So I'm running a DNS ad blocker service, which is listening on 53. So in my network, the primary DNS server is .150, which is the same machine I'm running this on. I, in my mind, think this is fine because really what I'm assuming Docker is going to do is send that query out to the host machine, and it's going to communicate to the host machine and get that traffic back because it's really the same actual machine. We're just in a virtual network. So let's see what's happening. We see this is a response coming back. This is a response from myself for some reason going to the gateway. And why is that happening? So let's trace one DNS query through. From me to 10.0.10.150 is this query. Now let's look at the response to this query. Okay, because the DNS queries are actually tagged with a identifier. So this is 4DC7. So the response 4DC7 is over here, but it's actually coming from 172.17.0.1, which is odd because really I sent it to 10.0.10.150, not 172.17.0.1. For those of you who don't know Docker, 172.17.0.1, this is the IP address of the gateway in Docker. Okay, so the gateway to this virtual network that I have spun up for this is .1. So for whatever reason, I'm sending the packet to 150 and getting a reply back from .1, which makes sense from a machine perspective because that's .1 and .150 are the same machine. But I should be getting the packet from 150 because my machine is not expecting a request from .1. And so what I think is happening is that in this case, let's just look at this query. This query goes out. It comes back with an IP address that I'm not actually anticipating on my machine. And if you know about how sockets work, there's no socket open for this address. Like my machine is not ready to receive a packet from .1. It's waiting for a packet from .150. So what my machine does is actually send a DNS destination unreachable message, port unreachable, back to the gateway because it's like, well, why are you sending me something? I don't need this. But what is the effect of that, right? Well, let's do something else. Sometimes in Wireshark, it's actually nice. Looking at time of day is good, especially when you're trying to correlate something to an event in a log. But what you can do is go to View, Time Display Format, and let's do seconds since beginning of capture. This helps you look at things in a relative fashion, right? How long does something take? So let's see what happens here. At time 0, we have, the first query goes out. We get a response back in about 20 milliseconds. That's not bad. But look at this. From this going out to the next time this runs, it's 5 seconds, right? Remember, the good script, speed test host, this was all done within 5 seconds. From the time we started the script here to the time that we actually started transferring lots of data. That was 5 seconds. Here, with speed test, it's 5 seconds just to redo the queries. And it looks like the queries are going out again. Now the queries are going to 10.0.10.1. This is my secondary DNS resolver. Okay, remember how in DNS, you configure 2 different IP addresses, right? You configure primary and backup. They do that because in case one fails, you have a backup. So in my home network, the DNS server primary is 10.0.10.150 and the backup is 10.0.10.1. So what has happened is that my application, or the application running the speed test application, tried to get to this DNS server. It failed. It backed off for 5 seconds. And then it tried to get 10.0.10.1. Now 10.0.10.1 is actually not my Docker machine host. It's actually my router. This is .1. And I have a VPN service running on here. This is specifically 10.0.10.1. But I have a DNS server running here, sorry. And so when I send that DNS query out, the response I get back, let's 4DC7 again, 4DC7, comes back from the actual IP, right? So I send it to .10.1, I get it back from 10.1. In a response time that makes sense. And then look, right away, it kicks off that same connection to speedtest.net. So clearly something wonky is going on with DNS here, right? You can see that that's introducing at least a 5-second delay. Now let's see how this goes in terms of delays, right? Let's keep an eye on this column here for time. Now we go down here, we get more of these, we get more DNS queries, more port reachables, right? And then another gap, right? Same thing. DNS queries go out, nothing comes back. We gap 10 seconds. Now we do DNS queries to .1. Then we get more data transferred. Same thing happens here. Destination unreachable because of the same problem, right? It comes back from .1. We have 10-second or 5-second gap. Then we actually do it again. And then we get going to the next thing, to the next thing. Okay. So you can see here, I want to get to the point. Remember how the first actual request that transferred data was like a get to a JPEG? Let's go down and see when we actually see that. First get. Actually, let's change the filter to HTTP. So we have the same pattern, right? We have speed test config grabbing latency from the servers, and then random 500, 500. This is the file that we're pulling down to test. That's 91 seconds later. Now, if you remember the graph that we took, IO graph. Let's take that out. But remember, we were looking at this before. We said, look, 90 seconds. You can see down here. Keep an eye on this, right? When I move my mouse, 90 seconds. So my theory now is because we're having issues with DNS on the actual primary DNS resolver, it is somehow inducing this delay. We know why it's inducing the delay, which is because the DNS times out at 5 seconds, and then you try the secondary, it goes through. But I have a theory that that's actually screwing up the calculation this application is doing of my speed. So what I'm going to do, I'm going to try to actually, instead of utilizing the DNS on my server, right, 10.0.10.150 on the host itself, I'm going to reconfigure the container to run. Instead, I want to use Google DNS. Don't use any of the DNS in my network. Just go straight to Google. I mean, through all this stuff, but to Google and get that back. And that will help me prove out the theory whether or not it is actually an issue with DNS on this versus maybe it's just one of the problem out of many. Let's see what it looks like. All right, so back to VS Code now. Same script, speed it up high, right? I have a Docker run statement. Again, I'm going to run the container, mount the code again, speed test latest. However, what I want to do is actually put additional tag for DNS. This allows you to set the DNS server of the container itself, of the operating system in the container. If you don't do this, what's going to happen is the container is going to inherit the DNS settings from the host. In this case, I showed you before, it's 10.0.10.150 and 10.0.10.1. I don't want that. I just want Google. So I'm going to do DNS 8.8.8.8. Speed test latest. Get me into bash. And let's go. All right. So now what I'm going to do is I want to do just verify that the DNS setting took. So I'm going to do a cat of etc resolve.conf. You can see my name server now is only 8.8.8.8. Now it's the moment of truth. I'm going to go into the code folder. I'm going to run python speeder.py. Now, if this does work the way I think it's going to work, this should be done actually relatively quickly, right? I think the last example it finished with under 30 seconds. So let's see. And there you are. 61 megabit per second down, around 10 megabit per second up, and about 17 milliseconds of latency from within the container. DNS is always the root cause of every issue, apparently. But in fact, this issue, I was kicking myself after I actually figured out what this was. Because this is just an issue that we've actually had brought up in the NetProbe GitHub by several users. I want to show you that real quick before we end. So to end off, I realize after troubleshooting this a little bit the other night and figuring it out, that this was actually brought up in another forum, or specifically in the plaintext packets NetProbe Lite issues section. Someone actually brought up the same exact problem, well, at least the DNS problem, which is that when you're using Pi-hole in Docker, DNS seems to fail when you're actually trying to query DNS from yourself. So like some people had actually modified NetProbe to use like the host IP, again, just a visual reference, this IP, in my case, .150, as DNS name server 4. So if you know NetProbe, it's the one for your home DNS. And they were getting this error. And the error actually says in it, got a response from the gateway, right? The DNS server is this, and you got a response from this. You remember exactly what was happening. is that we were sending DNS queries to one address and getting them back from a different address. And that's why the host would actually eventually drop them and throw an error. So for this, there's a whole other fix for Pi-hole users who want to actually measure that. But it's funny that actually this came up and I didn't put two and two together until I thought about it. There's a whole other ramification of this in terms of how Docker handles self-referential IPs. So like, how do you actually connect to your own host IP from within Docker and not get it routing this way? I may open an issue with Docker later. But really, the point of this video was to show you how to actually create an environment that you can actually test something like this in a containerized environment, and actually how to do a little bit of troubleshooting within a containerized environment using Wireshark. That's it for this video. If you enjoyed it, please like and subscribe. And if you have any questions on the topic we've covered, please join the Discord server where we talk all things network. Until next time.